Alright, this is an update or some help for our homework 12 that we have due here shortly. So you guys worked on this earlier in the week, and I've gotten a lot of emails on some questions. And so each one of your groups has been assigned different locations. This is the Belfouche River, below the Belfouche, and the wastewater treatment plant at Belfouche, 0.7 million gallons per day. And so you are to look at what are the standards related to dissolved oxygen, the critical stream flow conditions and water characteristics. That again would be using the Streeter Phelps equations, critical in-plant characteristics, and so looking online and determining what what are some of the other discharge limits that are at this wastewater plant. And so you'd have to look at, for example, if you're doing Belfouche, look at the Belfouche wastewater treatment plant. That would be located on the South Dakota DNR website. So then we got to find some flow information. So ultimately what we're trying to accomplish here is to come up with a Streeter Phelps model. This is an example for Rapid Creek from a group from last year, looking at the DO sag curve. And so here we have the DO sag curve that comes down, and so it looks like pretty close to the mixing zone, or afterwards we're finding where this critical point is located at, and finding again where that is located downstream based upon some assumptions that we would have to make and some information. So you're going to have to look at several different websites. The first one is, where do we find this information for flow? So if we think about the worst conditions for oxygen saturation, would typically be under low flow warm conditions, and so we need to find out when that is historically. I imagine a lot of these rivers here in South Dakota probably received their lowest, warmest conditions, I would suspect even this summer, because it was certainly had a 100-year drought as what it appeared to be here in South Dakota. But we need to find this information. So you go onto the USGS websites, and this is USGS for the James River near Yankton on this particular example, and we can export all of this data. I'd suggest getting the daily data and export that into an Excel file, and then find out what that minimum flow rates are and when that occurred. Did it occur during an ice jam during the winter? That's not what we want, because the solubility of oxygen is much higher under winter conditions. So we would look at we'd be looking at the concentration under concentration or the flows under warm summer conditions, and so you want to look at those. And typically what is done is you're looking for the 7Q25. That would be the 7-day. So that would be the 7-day consistent low flow average, let's say. That would under for a 25-year time period. 7Q10 is another example for defining a standard. So the 7-day low flow average for 10 years, and you'd have to find that information. You can pull that off of the USGS website. There's some export functions, and you should be able to parse through that information and see what those typical flows are, or those low flows are, for your conditions. And then go on to the South Dakota DNR website, and so this is the administrative chapter 74:51:001 or 01 surface water quality standards. And so we got to look to see what type of surface water quality standards we have for our particular stream. And so it's based upon the fish. Most of the streams in South Dakota are typically warm water permanent fish propagation waters or semi-permanent fish propagation waters. The ones in the Black Hills, we have a number of cold water permanent and marginal fish populations. And so we can look into here and pull off some information. So we've got ammonia, nitrogen, DO. So we have to keep our DO a daily minimum of greater than 5 milligrams per liter. So that's really going to be our criteria for most of the lakes that are going to occur, or excuse me, most of the rivers in South Dakota. And so again, you are to essentially run the Streeter Phelps model and look at how where can we go? We need to make sure that we don't go for some of our rivers below this point. And so what would be the BOD discharge limit of the wastewater treatment plant that would minimize or make sure that we never go below that for our 7Q25 flow period? And so we're going to have to know what that BOD is at the wastewater plant and be able to monitor and model that information. So these are some examples from some student work before, and this is the James River in Yankton, South Dakota. And so looking for graphs like this, the critical DO, and this would be the DO concentration at some point located downstream. So hopefully that clarifies a little bit. We'll talk more about this on Thursday in class. One thing is when you look at the uncertainties associated with this, if you have your Streeter Phelps model, I assume you have a lot of assumptions of the variables that go inside of there. How do things change? Are those assumptions indeed correct? How do those assumptions change your particular model? And so you might look at some uncertainty, and so if you change one of the reaeration constants, does it do something like this where it goes down further? How sensitive is it? Does it shift that low point further downstream? And so we're looking for that type of data, and you can either present that in a table or in figures. So with that, we'll talk more about this on Thursday. Thank you.